computer scientists aren't actually usually famed for their emotional awareness. You know, an extrovert computer scientist is the one who looks at your feet rather than his own when he's talking to you. So why feelings? Well, I'm interested in the way that people can communicate with machines. And to understand that, I need to understand how people communicate with other people. And so I'm interested in parts of communication that computers actually lack at the moment. Computers are quite good at typing, maybe even speech, but they lack a lot of the subtleties that we have in conversations between people. So when I'm talking to someone, I look at their face and I see an expression. I listen to the tone of their voice as well as what they're saying. I watch their body posture and movements. And I use that to form an impression of what they're thinking. Are they interested or bored, understanding or confused? And I modify the way I'm giving my presentation accordingly. And people who can't do this are at a social disadvantage. It's people with autism spectrum conditions. And in that sense, computers are autistic. We've been running a series of projects for about 15 years now in the computer lab, trying to see if we can give computers a sense of emotional awareness, some sort of understanding of these social signals that are normal in human communication. And this meant we have to go back and try and understand a bit about how people communicate. And a lot of the early scientific work was actually done here in Cambridge by Charles Darwin. About 10 years after he published his book on the origin of species, published a book called The Expression of the Emotions in Man and Animals. And he was trying to understand if there was a universal language of emotional expression, particularly through faces, which maybe would give an evolutionary advantage to humans and possibly some other species. If you had this common understanding, you could do this operation of understanding what somebody was thinking just from watching their face. Darwin collaborated with a Frenchman, Darwin and Duchene de Boulogne, working in Paris. Together, they actually did some of the earliest scientific work that used photographs. Duchenne had been photographing various people in Paris with different emotional expressions on their faces and had collected a large portfolio of photographs, and he sent a copy of these to Darwin. Darwin was then trying to look at these and understand if people had a common understanding of what the pictures were showing. And the way that he did this was by crowdsourcing. Of course, there wasn't much of an internet in the 19th century, or at least it was mainly Morse code. So Darwin's mechanism for crowdsourcing was he invited people round for dinner at his house, and over drinks before dinner, he passed the Duchenne photographs round and asked people what they thought they could see in the expression on the faces. And he put the answers into a spreadsheet. And across the top of the spreadsheet, it says the number of the photograph, and down the side, the name of the person who was looking at it, Lord so-and-so, Lady so-and-so, and then in the cells he writes what they perceived in the picture. And he saw that there was indeed a consensus view. We actually repeated this experiment about 3 years ago using the internet, so we were able to do the same experiment as Darwin, but with several thousand times as many participants without having to buy them drinks or dinner. Interestingly, we found we got more or less the same perceptions of the photographs. The understanding of the emotions expressed in these pictures were consistent 130 years ago and now, and haven't actually changed that much. The words have changed slightly because language has changed, but essentially the ideas are the same. So there is a universal language of expression in the face, and it's interesting then to see if we can analyze it. And the sort of words that Darwin homed in on were 7 different emotion words. These are a fairly universal language, but it turns out they're rather rare mental states. You don't often feel angry with your computer. Well, you might feel angry with your computer, but not the sort of anger that's important for survival, which was what was interesting Darwin. And in fact, there's a rather richer language of emotions and mental states that we can use, which was developed by my colleague Simon Baron-Cohen in the Autism Research Centre here in Cambridge. And he has a language of about 400 very finely nuanced mental states. And you can then scatter these around and you sort of separate out, tease apart different understandings of mental states. And in fact, what you see on this diagram is a further way of analysing them. You can have a very rich vocabulary. This includes words that aren't just very visceral emotions, but sort of cognitive mental states, things about what you're thinking, things like understanding and confused, interested and bored. And you can spread these out in a two-dimensional plane, and you have an axis that's running, sort of a happiness axis running horizontally from sad to happy, negative to positive, horizontally, and a vertical axis which is the sort of energy involved from very passive at the bottom to very active at the top. And you can scatter the words around. And so this gives us several different ways that we can at least measure emotions. And then once we can measure them, we can start doing calculations with them. And that's exactly what we did. We built a system, point a webcam at somebody's face, and then what we do is find the face in the picture, and then analyze. There are various analyses going across here, and the little bars at the bottom are showing us which muscles are being activated in the face, and then from those we can make inferences about the person's mental state, both in the list of the taxonomy of different mental states, the words, and also in these two dimensions. And that's actually quite a useful tool. Most of the time people are neutral, it turns out. Sort of look of surprise occasionally. And you can see the trace running around these two axes of valence, happiness, and arousal, the sort of energy at the top. But what about other modes of communication? Another interesting one is speech. It turns out that with the face, you can sort of characterize these muscles, and that gives you a pretty good indication of what's going on. Voice is more difficult. It turns out that it's a much richer source of information. The energy, the pitch, the tempo of the voice are all important. And so what we find we can do is distinguish between two different mental states reasonably accurately. And so we have a system where we actually do all the pairs of comparisons. So if you're trying to distinguish one of 10 different mental states, you have to do something like 45 pairs of comparisons, and then you combine them in something like a preference voting system to actually see which one's most common. And actually this also allows you to have more than one emotion being detected at once, which is often the case. We often do express more than one emotion at a time. So we can analyze speech. Facial analyses are universal, so once we've got this system, it works more or less on any person, independently of cultures. And the same is true of the voice analysis. We can actually build this system and train it, evaluate it with English language, and it actually works for other languages. We tried Hebrew, which is a very evocative and emotional language. So this is all good fun, but it turns out that the face, the voice, are rather limited channels. The rest of the body is important. So here we have some photographs of tennis players with their mouths wide open, and obviously something important has happened, but you can't actually tell just from the facial expression whether it's something good or something bad. But if we add their body, we can actually see just from the simple hand motion. An open hand motion is, oh no, it's disappointment. And a clutched fist is, yes, I've done it. So in fact, in being able to interpret the person's body movements, the dynamics of the movement and the gestures is very important. And the trouble is that this actually turns out not to be so universal. It's a very personal thing. If you analyze a person's body, and the way that we actually do this is by making them wear a rather elegant leotard covered with reflective dots, and then we have a camera system that can monitor the movements, and we can measure all the different angle joints in the body, and the speed of movement of the muscles and the accelerations. And combining these, what we find out is what the person is doing. So you have to sort of factor that out. And then you discover who's doing it. Different people have very different dynamics to their movement. So you have to actually train this on each individual. But then when you've done that, you can actually infer how they're doing it, whether they're doing it in a happy or sad way. So we can actually analyze body movements as well. So those are three important channels for monitoring people's emotional expression: face, voice, and body posture and gesture. Well, then, can we actually make a computer exhibit these? And we've been looking at ways of making robots that are emotionally expressive. But the real question is, if we give the computer a human-like appearance, does it change people's perception of it? We made a robotic head. This is a head with something like 24 motors inside it, replicating the main muscles inside the human face, and then it's covered with a very high-quality prosthetic material. We can then manipulate this to replicate the emotional expressions that people show. And we did experiments to see if this made people more confident about talking to a computer. The results were mixed, I have to say. It's really very difficult to control the motors accurately, and people are extraordinarily good at discerning peculiarities in facial expressions. By and large, people just find this rather creepy. The one thing we did do successfully with it was actually training doctors who were treating patients with dystonia, which is an uncontrollable muscle spasm in the face. And junior doctors, when they're training to deal with these patients, often show disgust in their faces, and that's not a good thing to do when you're talking to a patient. But actually, if we exposed the doctors to this robot showing random muscle movements, which it turns out to be really good at, we could actually then precondition them so that when they met real patients, they were more relaxed and could just look more empathetic. So this was perhaps the main use for this. The other thing about robots, incidentally, if any of you ever go into scientific research, they're brilliant for getting press attention. People love robots. They're arguably not terribly useful. So what are the uses? One of the areas that's been interesting us a lot is the possibility that we might use this in command and control systems, and where you have a command and control operator who's perhaps getting stressed, confused, and we want to do something to detect that. And a good model for this is actually driving a car. If you're driving a car in an unfamiliar city centre, you're late for a meeting, there's lots of traffic, you're lost, the last thing you want is a satellite navigation system that tells you to make a U-turn. It would be much more useful if the satellite navigation system removed distractions. It could stop your mobile phone from ringing. It could even turn off the radio so you didn't have that distraction. It might even let you drive in the wrong direction for a bit until you recover your composure and then bring you in for another attempt. We wanted to do experiments on car drivers. The trouble is, if you're trying to do a scientific experiment, you have to repeat it lots of times, and it's really difficult to get all the traffic in Cambridge rewound and then replay in exactly the same way. So we use a driving simulator, and we monitored people's facial expressions while they were doing it. We also gave them mental arithmetic to do while they're doing it to try and stress them a bit. And the trouble was, we got some sort of result. They'd crash, but they didn't care if they crashed because they knew it was only a game. And so we weren't really getting any significance in the results. So we hit on another way. We just reprogrammed it with some of these four-rotor drones that you've perhaps seen that you control from your mobile phone. We reprogrammed it so that it ran on the Edurome wireless network, which means you can drive it longer distances, and then set it up so that in our lab you can fly the drone, and you get the video from the drone coming back to the screen in front of you. You can then go off for a trip round the building. This is great, incidentally. It's a wonderful way to irritate your colleagues when you fly this thing into their offices, have a look at them, and then fly out again. But the important thing scientifically was people felt a terrific emotional engagement with this. They could hear it going down the corridor, and if it crashed into the wall, somebody had to go and pick it up. And we actually found quite significant differences in their physiological reaction when they were flying this under difficult conditions from driving under difficult conditions. So what else might we try and do with a system like this? Well, it turns out that when Darwin wrote his book, he was interested not just in human expression of emotions, but also animals. We've been wondering, well, maybe we can study animals as well. And you may wonder, why would you want to study animals? Well, it turns out it's really quite important. There are a lot of animals, and their welfare is a significant issue. And so we've been looking at sheep. Sheep have very expressive faces. You probably haven't spent long looking at a sheep's face, but in particular, if a sheep is in pain, there are quite distinctive movements of its ears, its nostrils, its cheeks, and so we've been rebuilding our facial tracking system so that it can track a sheep's face instead. We can now more or less do this fairly accurately. It turns out that sheep aren't very good at posing in front of the webcam the way that you'd like, but you can set a camera up at a feeding trough in the field, and as the sheep come to feed, you can get a reasonable view of their faces, and we can now track this, and we can then make inferences about is this sheep in pain? And that's quite important, because sheep spend a lot of their time out on the hillside. They're sitting there or strolling around. They get diseases in the foot that cause them extreme pain, and we can now detect those by monitoring their faces, using the radio tags. You know which sheep it is has come, and you can then actually send somebody out to find it and treat it. So it turns out there are applications for animals and welfare, and we're also doing experiments with human welfare, things like long-term monitoring of depression. You can actually monitor someone's facial expression and other physiological signals over time, and this gives you a very long-term picture. All of which is by way of saying this is a whole new area. We've been at it for a few years now, but there's so much more to do, and it's great fun. It's great fun to come and talk to you about it, but I should perhaps just say I just come and do the talks. I don't actually do any of the work. I'm very lucky to have an extremely brilliant team of people who've worked with me over the years. They're the ones who do the actual work, and I sort of arrange that they get paid, and then I come here and claim the credit. But these are the people who actually deserve the credit. Thank you very much.